there! In this video lesson, you will be learning how to calculate the volume of a cone. So this is the next lesson in our Common Core unit for volume. And up until now, we have been talking about finding the volume of cylinders. And today we're going to shift gears a little bit and start talking about cones, like an ice cream cone, right? So since this is a different shape than a cylinder, this is a cone, not a cylinder, we have a new formula to work with. And the formula to calculate the volume of a cone is shown here on this page. It can be found by taking 1/3 times pi times the radius squared times the height of the cone. So really, if you look at this formula, it looks very similar to, if you remember this part, pi r squared, that was area of a circle, right? And then if you remember when we did volume of a cylinder, it was pi r squared times h, right? And then now that we're talking about cones, really the new part is adding the 1/3 into that formula. So we've worked with pi r squared for quite a few days, and then we did pi r squared times h, and that was volume of a cylinder, and now we're adding in that 1/3. So the formula is now 1/3 times pi times radius squared times height, and that's how you calculate the volume of a cone. So just to be sure we're all clear about where we're going to be finding our measurements as we're looking at these cones, there's a nice cone kind of turned upside down, and the radius, of course, goes from the center of the circle out to the edge, and then the height would be from the center of that base straight up to the vertex. So we're going to be looking for those measurements as we're looking at these cones today. We have a total of 3 examples, so this shouldn't take us too long. I would highly suggest you have some paper handy to take down these notes. Definitely going to want to fire up your calculator, as this is all truly calculator work. I'm going to be expecting you to write your formula for each problem and show your steps, as well as we have to remember to label our answers with whatever our units are to the 3rd power. So here we go. This page says find the volume of each cone and round to the nearest tenth. Alrighty, so step 1 is always going to be to write your formula. 1/3 pi radius squared times the height. Alright, so at this point I just need to plug in the radius value and the height value. Shouldn't be too tough. It's going to be 1/3 times my pi button times my radius, which is 4.3, which I'm going to have to square, times the height, which is 11. So I fire up my calculator and I type in the fraction 1/3 times the pi button times 4.3 to the 2nd power. Or if you wanted, you could take times 4.3 times 4.3 again. And times 11. And when I round to the nearest tenth, this isn't too tough. That's what my calculator says. So when I round to the nearest tenth, the 8 makes the 9 round up, and when the 9 rounds up, it carries over into the ones place. So I end up with an answer of 213 meters cubed, or cubic meters. Not too tough. See what I mean? It's really all calculator work. You have to write the formula, show me what values you're plugging in for the radius and for the height, and then you simply punch it all in a calculator. But unfortunately, that's where a lot of students make their mistakes. They aren't very accurate or careful when they're entering data into their calculator, and unfortunately, right, what do I say? Garbage in, garbage out, right? If you don't put the right data into your calculator, you're certainly not going to get the right information out as your answer. So be very mindful, be very careful. And make sure you're entering the 1/3 and the pi button and the 4.3 squared and the height. And make sure if they give you a diameter that you cut it in half, because we're looking for a radius in this formula. So there's a lot of things to keep in mind, even though it's really all calculator work. Let's look at this guy, problem number 2. Oh, see, perfect example. Here is a cone. They're showing a diameter of 4 inches. So that's a problem, because I don't need the diameter, I need the radius. And in this cone, the radius would be 2 inches, not 4 inches. All right, so we got to keep that in mind. Step 1, write my formula. 1/3 times pi times my radius squared times the height of my cone. All right. What's the radius? Not 4, it's 2, which I'm going to square, times the height, which is 4.5. So on my calculator, I enter 1/3 times the pi button times 2 to the 2nd power times 4.5. I do a little bit of rounding, and I end up with 18.8 inches cubed or cubic inches to the 3rd power. Right? Hopefully you are able to arrive at the same answer on your calculator. Now I know you guys love this last problem here. This is the problem where they give you the volume, and then they also give you either the radius or the height, and you have to find for the other one that's missing. You have to solve for either the radius or the height, whichever one they don't give. So these are those problems where you almost have to work backward. It's more like solving an equation than simply working a formula. Number 3 says the volume of a cone is 1,281.8 inches to the 3rd power. The radius is 12 inches. Find the height of the cone. Oh, okay. Hey, I'm missing a fraction in my formula. I just realized it must not have copied. It's missing the 1/3. I better sneak that in there. Holy cow. All right. So there's your formula. Let's plug in our values. So it says that the volume is 1281.8. That goes in that spot. Equals. I've got my 1/3. I've got my pi. Radius. Oh yes, the radius is 12, which I have to square, times the height, and that's the one I don't know. So that one stays the variable h. So, what would I tell you to do? I would tell you to do what you can do. So I would square that 12 and make that a 144. Nothing else at this point is going to change. But I do like to do that. I like to square that number so that instead of 12 to the 2nd power, now we've got it expressed as 144. So let's think back. If we're trying to solve for h, right? This is our variable. This is the guy we don't know. This is the guy who wants to be alone, right? Those variables want to be alone. They don't want to have any numbers near them. Well, he's got all kinds of numbers on his side of the equation bugging him. I see that he's being multiplied by a 144, he's being multiplied by the pi, and he's being multiplied by 1/3. So basically what you're going to do is do the opposite of all of that. You're going to divide by 144 on both sides, you're going to divide by the pi button on both sides, and you're going to divide by 1/3 on both sides. And when you do that, when you divide by all those 3 pieces, then h will be alone, h will be happy. So think of it this way. You're going to divide by 1/3, and that'll cancel, which means you're going to have to divide by 1/3 over here. You're going to divide by pi over here, so that cancels, but then you're going to have to divide by pi over there. And you're going to divide by 144 over here, so that will cancel, but you're also going to have to divide by 144 over there. So on your calculator, in any order that you would like, take your 1,281.8. Divide by 144. Then divide by pi. Then divide by 1/3. And when you do all of that, fingers crossed, you should get an answer of 8.5. And it's plain old inches. It's not inches to the 3rd power. Because we're finding the height, it's just plain old units. So it's 8.5 inches. So this cone is 8.5 inches tall. It has a radius of 12 inches and ultimately a volume of 1,281.8 cubic inches. All right, so give that a shot. Make sure you can get that answer on your calculator. The very last problem is a problem that we probably won't do on the first day of class when we work with this formula. We'll probably do this either on the 2nd day or maybe even the 3rd day. This is called a composite figure, and the reason it's called a composite figure is because it is actually a figure that's made up of two separate three-dimensional figures. This composite figure has a cone at the top of it and a cylinder as the base of it. So we actually have to solve two separate volume problems here, and then we're going to put our answers together. So, to find the volume of a cone, 1/3 pi r squared h. And to find the volume of a cylinder, it's just pi r squared h, right? Different three-dimensional shapes have different volume formulas. So that's step one for me. Step one for me is write the formulas for each of my shapes so that I can keep my math straight. Maybe it would even help to do like this, right? Give yourself some separate working space. So let's focus on the cone to start with. I need to know the radius and I need to know the height of the cone. Well, I'm looking at this cone over here and it doesn't really seem to have a lot of measurements in it. So I need to do some investigating. I look at my design here and I see down here that looks like the diameter of that base is 8 meters. My calibration is off a little bit. You know how crazy that makes me. Okay, there. If the diameter is 8 meters, then up above on this cone, I can tell you that the radius must be 4. All right, so now I know the radius is 4. Good. How about the height of the cone? Well, the height of the entire design is 20, and the height of the cylinder is 14. So if the whole thing altogether is 20 and the cylinder is 14, that must mean that the height of the cone right up here is 6. Okay, great. So there are my measurements for the cone. Let's plug my numbers in and do the math. I'll do this one in green, I guess. I need to take 1/3 times pi times 4 squared times the height of the cone, which is 6. So in my calculator, I do 1/3 times the pi button times 4 to the second power times 6, and I end up with an answer of 100.5 meters cubed, or cubic meters. Awesome. Now, let's talk about the cylinder. I already wrote the formula there. It's pi r squared h. So I'm looking at my cylinder now, over here on the left, and I see that the radius of my cylinder would be half of the diameter. That's a 4. And the height of my cylinder over here is 14. Awesome. Now I've got my values. I take pi times, again, the radius is 4, which you're going to square, times the height of the cylinder, which is 14. And I punch it all in my calculator. I might have to do a little rounding here or there. And I get an answer of 703.7 cubic meters. Great. So now I know the volume of the cone. I know the volume of the cylinder. I better put those two volumes together, and that would give me the overall volume of this composite figure. So I add those together. That says add. How about that? I get a total volume of 804.2 cubic meters. Yay! Good job. You calculated the volume of a composite figure. And as I started this problem and said, we won't be working with composite figures probably on the first day of this practice in class, possibly on the second day. If not, then if I decide to make this a 3-day lesson or a 3-day concept, then we will definitely be doing composite figures on the 3rd day. But definitely not on the 1st, possibly on the 2nd. And if not the 2nd, then the 3rd. All right, so this is the formula we're going to be working with over the next few days in class. Thanks for checking in. Thanks for taking notes. I appreciate your hard work, and I will see you in class.